दोस्तों तैयार हो जाइए महा बचत सेल के लिए। इससे बढ़िया मौका नहीं मिलेगा जहां आप मजे ले सकते हैं बचत के।
मे यू सेव मोर, यही है हमारा वादा।
इस 28 से 31 मई सभी सुपर कोचिंग पर आपको मिलेगा अप टू 90% ऑफ एंड 50% की एक्स्ट्रा वैलिडिटी। ये वो मौका है जहां आप अपने सपनों को साकार कर सकते हैं, आप अपनी ख्वाहिशों को पूरा कर सकते हैं। तो अगर आप तैयारी कर रहे हैं एसएससी, बैंकिंग, टीचिंग, यूजीसी नेट, सीएसआईआर नेट, ईपीएफओ, स्टेट पीएससी, यूपीएससी, डिफेंस जैसे एग्जाम की, तो आइए इस महा बचत सेल में साथ मिलकर धूम मचाएं और अपनी सेविंग्स को यादगार बनाएं।
Hi, good evening, everyone. This is Shefali Singla, and in this session, we are going to continue our discussion on indexing. So, already we have talked about what is sparse index, what is dense index, and what if we are given with a search key as a key field and the file is ordered, then what sort of index will be created. So, now we will be moving on to multi-level indexing, then we'll look at the disadvantages or drawbacks of static multi-level indexing that will result into the dynamic multi-level indexing, in which we will be covering the concept of B tree and B plus tree. So basically this will be the agenda for today's session and tomorrow's session, because we have to talk about each and every concept of B tree and B plus tree. All right. So let's have a quick overview of what we have covered in indexing. तो जब भी हम index बनाते हैं, there are two parameters which we are considering, whether the file is ordered or the file is unordered. If the file is ordered and unordered, these are the two options. And after that, if the file is ordered and its index is built on the basis of the key field, जो search key है, that is key, then we will be constructing the primary index. Then we'll be constructing the primary index. If the file is ordered and we are doing the search on the basis of the non-key field, then we will be constructing the clustering index. Can somebody tell me that primary index will be sparse or dense? And if the file is unordered, doesn't matter whether we are doing the search on the basis of the key field or non-key field. Here we will be getting the secondary index. This will be secondary index. Now question arises is, what is this primary index? We are talking about the first level index, that is base that is constructed on the basis of the database file. So here, if the index is a primary index, then it can be sparse or dense, but definitely will prefer sparse because the number of entries are less in the sparse index. Agar number of entries kam hongi, to definitely the number of blocks required to construct the index will also be less. If it's a clustering index, then surely it's always the sparse index. And if we are getting a secondary index, so this index is always the dense index. So on the basis of this, we had done the numerical, जिसमें हमने ये सारे parameters, what is sparse, dense, कितनी number of entries आएंगी, we have already discussed this. And we know that IO cost using indexing is IO cost using index. यहाँ पे आपके पास single level index है, so it depends on the number of blocks in the index file. So that is log base 2m, where m is representing the number of blocks in the index file, where m is representing the number of blocks in index file. Why are we taking log base to m? Because index file is always sorted and it always contains the unique values. Correct? Anyone having any doubt on this point? Now we have said that if the size of the index file is too big, then we might not be storing the whole index file in the main memory, then there is a possibility that the index file is also available in the secondary memory. So from there, whatever index page will be required, we will be transferring that from the secondary memory to the main memory. That is possible only when we have the concept of multi-level indexing. This multi-level indexing is saying that we are constructing the index over the index. What do I mean by this term? Index over the index. Let us assume that we have a database file. Okay, so here we have a database file. This is the database file, which is divided into the blocks. And let us assume that n blocks are there. This is block 1, block 2, block 3, block 4, and so on. This way we have n blocks. Okay, now on the top of this database file, we are constructing the first level index. This index can be sparse index or dense index, depends on कि जो आपके पास file given है, what is its structure, whether the key field, whether the search key is a key or not, like that. So we are coming up with the index. This can be sparse or dense index. So here comes the index file. In the index file, we know that the number of blocks are less than the number of blocks required in the database file. So here, let me call this as block 1, block 2, block 3, and so on. Like this, we have m blocks. This is what we have already covered. And we know that the number of blocks in the index file is less than, kitne blocks hai? M blocks. M blocks are very, very small as compared to the value of n. Very good evening, Shubham. Okay. But if the size of this index file is too big, then we cannot accommodate this index file in the main memory. So we might be interested in constructing the index over the index. So index के ऊपर index कब तक बनाएंगे? Until we get a single page in the index file. We keep on constructing the index over the index until we get here a single block. Now this single block, this index block will be stored in the main memory. And let me call this as pth level index. Pth level index. This is first level index. Okay, so here we'll be having the second level index and so on. Some B1, and let's assume that the number of blocks are P blocks are there. So here the number of blocks in the index file, this is second level index. Second level index. Here the number of blocks are very small as compared to the number of blocks in the first level index. This is m. Okay, is this clear? तो अब यहाँ पे क्या होगा? आपके पास main memory में only one block is there, and this index, first level index onwards, it will be pointing to different blocks. So जहाँ पे भी entry है, it will be pointing to that block. Only that block will be transferred from the secondary memory to main memory. Similarly here, there will be the entries. So these entries are also this is also the sparse index. So depending on the required block number, it will be just transferring that particular block from the secondary memory to main memory. And finally, this is pointing to the index file. This index can be sparse or sparse or dense index. Okay. So this way, we are going to construct the multi-level index over the database file. So already we have written this index can be sparse or dense, whereas second level onwards, this is always the sparse index. ये क्लियर हुआ? ओके, तो एजेंडा इज कि हमारे पास एक ही ब्लॉक आ रहा है मेन मेमोरी में, एंड ऑन द बेसिस ऑफ द रिक्वायरमेंट only the specified blocks will be transferred. Let us assume that we have p levels of index. index file p levels में बनी है, then what will be the IO cost using multi-level indexing? IO cost using multi-level indexing. मतलब कितने ब्लॉक्स हमें सेकेंडरी मेमोरी से मेन मेमोरी में ट्रांसफर करने पड़ेंगे? फर्स्ट ऑफ ऑल, this block is there. On the basis of this, we will be transferring one block, second block. So it depends on the number of levels. हर level से एक block आ रहा है. Number of levels in the multi-level index file plus one block, that is to access the actual record from the database file. So this is nothing but IO cost using multi-level indexing is the number of levels of index file, levels of index file plus 1, which is very, very small, and we need not to store the complete file in the main memory. Okay, this is the concept. Now, if we talk about the various parameters, already we have discussed that the blocking factor of this index file, first level index, will be greater than the block factor of the database file, because block factor is nothing but that is the block size upon the record size. Block factor is block size divided by record size. And we know that record size of the database file is greater than the record size of the index file. So definitely here the block factor of the database file is small. That means the number of entries in one block of the database file will be smaller than the number of entries in the index file. Now you may ask a question that whether this is the first level index, second level index, or so on. So one thing is clear that in the index file, we are just storing the key field and the pointer field. In the second level index also, we will be just having the key field and the pointer field. In all the level in on all the index blocks, we will be having just the key and the pointer. So we can say that the entry size of all levels of index will be same. And we also know that the block size is also same for all the levels of files. So in simple terms, we can say that the block factor for all the index files will be same. Block factor means the number of entries in each block of the index file will be same at all the levels of index. Make sense? So let me write this point here for your reference. Block factor of first level index is same as that of the block factor of second level index, and so on. So conclusion is block factor of all the index files is same. Any doubt on this point? Because on the basis of this, we were asked one question in the GATE exam. We will be talking about that once we are clear with all these concepts. Okay, so basically the concept of multi-level indexing हमने conceptually understand कर लिया. So let's look at the theory. With the growth of the size of the database, index will also grow. जैसे जैसे database file का size बढ़ेगा, index का size भी बढ़ेगा. As the index is stored in the main memory, क्योंकि हम index को main memory में store कर रहे हैं, तो single level index might become too large a size to store with the multiple disk accesses. So it's sometime becoming too large to store that in the main memory. So the multi-level indexing segregates the main block into various blocks so that the same can be stored in a single block. तो हमने एक index file को छोटे छोटे blocks में divide कर दिया, and we are doing this indexing till we get a single block. Okay, but point to note here is important point. From second level index onwards, first level index can be the sparse index or the dense index because it's directly related to the database file. But from second level index onwards, index is always the sparse index, whereas the first level index can be sparse or dense index. Make sense? So this is about the multi-level indexing. On the basis of this, let's see what sort of question can be asked. Then we'll look at the drawbacks of multi-level indexing. But before moving to the question, so guys, those who are new on this channel, you can subscribe the channel and you can also join the Telegram group if you want to get the important notifications and the PDF of all the YouTube sessions. So जो भी session होता है in another 15 minutes after the session gets over, in another 15 minutes I'll share the PDF of this YouTube session in the Telegram group. तो आपको notes लेने की जरूरत नहीं है during the session. You just focus on learning the concepts and after the session get the PDF, revise the concept, prepare your notes. This is how you can prepare well for any topic. So the benefits of joining this Telegram group is you will get the PDF of all the YouTube sessions. You can participate in the doubts and the discussion which is posted by you or the other students. Directly interact with me. You can participate in the quiz and the polls. You can search for joining this Telegram group. You can search for Shefali ma'am Testbook, or you can directly join it using the link which is given in the description box. Okay, so that's the third link. Just go through it. अगर नहीं मिलता है तो I'll share my screen and you will be able to know that where is it available. Okay, so anyone having any doubt in the concept of multi-level indexing, shall I move to the question? And this was actually a previous year gate question. So question is on the screen. I want you to find out, I'm not providing you any options, I want you to find out the number of first level and second level index blocks in multi-level indexing. This was actually the gate question where the four options were given, but if according to the latest pattern this question will be asked, obviously this will be coming under the numerical answer type question, so that's why I have not provided any options. We'll expand this question more in order to find out the total number of blocks of the index file, kitne index banenge, what will be the IO cost, like that. Okay, so read out the question. You have 2 minutes. Try to see that what we need to do in order to find out the first level and the second level index blocks. अगर कहीं पे doubt है, you can write that in the chat section. I'm continuously monitoring your messages, and as soon as any query will come up, I'll surely discuss that. Here we are given with a file of some number of records, and okay, let's take out the important information. So number of records in a file, in the database file, is number of records we are given as 16384. 16384 records are there, and that is nothing but 2 raised to power 2, 4, 8, 16, 2 raised to power 14. Each record is 32 bytes long. That means the record size is given. This is for the database file. Record size is given as 32 bytes long, and its key field is of size 6 bytes. Key is of 6 bytes long. The file is ordered on a non-key field, and the file organization is unspanned. So file is unordered on a key field means looks like it's the clustering index, but directly will not go for it. It is saying that the file is stored in a file system with a block size of 1024. So block size is given as 1024 bytes, that is nothing but 2 raised to power 10 bytes. This is 2 raised to power 5 bytes. I'm writing this in the form of 2 raised to power because it will make the calculation easier. It's completely optional. The size of a block pointer is 10 bytes. Key field is given as 6 bytes, and the block pointer, that is the pointer, is of size 10 bytes. Pointer size is 10 bytes. If the secondary index is built, अब हमें क्वेश्चन में दिया हुआ है कि अगर हम सेकेंडरी इंडेक्स बनाते हैं एंड इफ वी यूज द कॉन्सेप्ट ऑफ द मल्टी लेवल इंडेक्स स्कीम, देन द फर्स्ट लेवल इज यूज्ड टू स्टोर द सेकेंडरी इंडेक्स. अगर मल्टी लेवल इंडेक्स स्कीम यूज करते हैं टू स्टोर द मल्टी लेवल इंडेक्स, देन व्हाट विल बी द नंबर ऑफ ब्लॉक्स इन द फर्स्ट लेवल एंड द सेकेंड लेवल index. Okay, so this means that we have to work on the secondary index. Non-key field है. Secondary index is always, anyhow, we are not going to consider this. Sometimes you may come up with the some statements in the question which are actually not used in the question. That is simply given just to confuse you guys. Okay, so यहाँ पे clearly बोला हुआ है we have to construct a secondary index. Can somebody tell me that secondary index is sparse or dense? Since it's a non-key field, we know that secondary index is always dense index. That means जो आपके पास first level index बनेगा, that will be the dense index. First level index will be the dense index. Dense index means the number of entries in the first level index will be equal to the number of records. So number of entries in first level index is equal to number of records in the database file. How many records are there in the database file? That's 2 raised to power 16384. That is 2 raised to power 14 records are there. Point number 1. After that, we have to find out the number of blocks at the first level index. So first of all, we'll be finding out the block factor for index file. Block factor of the index file. That comes out to be the block size upon the record size. Index entry size. What will be the index entry size? Index में क्या enter होता है data? That's the key and the pointer. So index entry will be index entry size depends on the size of the key and size of the pointer. Key field is given as 6 bytes long and pointer is given as 10 bytes long. That comes out to be 16 bytes. Block size is given to you in the question itself. So just consider that block size is 1024, entry size is 16 bytes, or you can consider this like 2 raised to power 10 bytes and 2 raised to power 4 bytes. So ultimately this comes out to be 2 raised to power 6. Now we are interested in finding the number of blocks. Entries here 16384. So number of first level index blocks. First level index blocks. I hope this is not going behind my image. So number of entries, कितनी entries हैं? 2 raised to power 14. एक block में कितनी entries आ सकती है? 2 raised to power 6. So this is coming out to be 2 raised to power 8. That means at the first level index will contain 256 blocks. Now from second level index onwards, this is always going to be the sparse index. Always sparse index. This means that number of entries in second level index, number of entries in second level index is equal to the number of blocks at the first level. Number of blocks in first level index file, and that is nothing but that is 256. Now we have to find out the number of blocks. So number of second level index blocks. Number of entries are 256. Block factor is, we have already calculated, that is 2 raised to power 6. That is nothing but it comes out to be 4. That means second level index blocks are, index block is 4 blocks. यही आपसे पूछा था फर्स्ट लेवल इंडेक्स में कितने ब्लॉक्स होंगे, सेकंड लेवल इंडेक्स में कितने ब्लॉक्स होंगे. सो आंसर फॉर दिस क्वेश्चन इज respectively it's 256 in the first level index and 4 blocks in the second level index. So this was one of the option, I guess that was option C. So you had to opt it for the right answer. Okay, this is about finding the first level index and the second level index. How many levels can be created? We will construct the index over the index till we get a single block. Second level के बाद भी हमें single block नहीं मिला. In the third level index, the number of entries will be 4 because second level पे आपके पास 4 blocks हैं और in one block we can store 64 entries. So that means at the third level we will be just getting one block. Let's continue. Original gate question is over. I'm going to continue this question in order to answer the remaining parts of the question. So total index blocks. First level index में first level पे number of index blocks. Okay. Let me write here. Number of index blocks at the first level, at the second level, at the third level. At the first level, number of index blocks are coming out to be 256. At the second level, it is coming out to be 4. At the third level, this comes out to be 1. So we'll stop here. So total number of index blocks is nothing but that is 256 plus 4 plus 1, that is equal to 261. Number of index level, 3 levels are there, that is 3. IO cost using multi-level indexing, that is nothing but number of levels, number of index levels plus 1. So here we are getting 3 levels of index. So that is 3 plus 1. So IO cost using multi-level indexing will be 4. Make sense? So this is all about the multi-level indexing. But यहाँ पे जो हमने indexing consider की है, that is static multi-level indexing. I'll discuss that. What do I mean by static multi-level indexing? Anyone having any doubt on this point? Guys, quickly give me the confirmation if it's clear. आप देख पा रहे होगे the data, the question is same, problem statement is same, questions different hai, and this were not in the this was not there in the gate paper. Gate में सिर्फ और सिर्फ first level और second level index blocks पूछे थे. You can search for it if you want to. Make sense? Interaction level is very, very low. Okay, so अभी जो हमने index file की बात की, that is static multi-level indexing. Basically what is happening, let's say this is the first level index. This is the first level index And before this, here we have a database file. Now you know that what is first level index and second level index. So here we have the database file, which is divided into the blocks. N blocks are there: block 1, block 2, block 3. Anyways, here we have the first level index where we have M blocks. Now on top of index over the index, we have the second level index. I'm just considering till second level index. And let us assume that here we are constructing the sparse index. So entries are like 1, 2, 4, 6, 8, 10, 12, 14, 16, like this. So when we are constructing the index, we might be storing here 18, 20, like this. So we might be just having the first key address, first pointer only. So the next one is, it is starting from 6. So we are going to store here 6. Here we are going to store 12, like this. Okay. Next block में आपके पास 18 आ गया. Now again, this is a sparse index. So that means it is going to contain the first entry from each block. So 1 is getting stored here, 18 is getting stored here, like this. This is from the second block. Now what happens if I want to insert a new record in the database file? अगर file में हम एक नया record add करते हैं, let's assume that in one block we can store only 3 records. So I want to insert a record with the value 3. Now what will happen? 4 records नहीं आ सकते, so it is a case of overflow. यानी कि block 1 में आप एक ऐसा record insert करवाना चाहते हो, but block 1 is already full. If the size of the block is static, if this is static multi-level indexing, then this is a case of overflow. Overflow means it's already full and still we want to insert some more data, so it results into overflow. So the solution is, या तो ये सारी entries को shuffle कर दो. So here we'll get 4, 6, 8 and here we'll get 10, 12, 14, like this. But if the changes are taking place here, if you are shuffling the data blocks, then in that case we have to change the index file. अब यहाँ पे second block कहाँ से शुरू हो रहा है? It is starting from 4. It is starting, here we'll get 6, here we'll get 12. If the changes are taking place here, it will reflect the changes to take place here as well. So this means that if we are inserting a new record in the database file, we have to shift the database. This is one solution. Shift the database means we have to shift the data records based on the new inserted value. जो आपने नई value insert किया उसके basis पे आप shuffle करोगे records को, which will result, जब ये records change होंगे तो first level index change होगा, first level index change होगा तो second level index change होगा. Basically, it results in changing the entire database, which is not a feasible solution. Other solution is, instead of shuffling the data, because पूरी database file, पूरे index files में भी change करना पड़ रहा है, so instead of doing this, let's create here the overflow blocks. जो data आ रहा है, here will create a chain of overflow blocks. But if there is a long chain of the overflow blocks, then searching for any record will become difficult, it will become complex. So that is the problem that is coming because of insertion. Similarly, if we want to delete any entry, then also there will be a problem coming up. What sort of problem will come up? Let us assume that I want to delete one entry like 6. A block कहाँ से change हो रहा है? 8 से start हो रहा है. Okay, this is one problem. तो या तो इस block को खाली, इस position को खाली रखो, leave the whole, it will result into leaving the whole. Or if this record is deleted, then shuffle the remaining entries. अगर shuffling होती है, again it will result into changing the entire database file. Database file में तो changes होंगे होंगे, plus index file में भी changes होंगे. ये क्यों हो रहा है? Because here there is no scope of the empty slot. Okay, जब एक block full होगा, then we are going to the next block, then to the next block. So there is no option, there is no possibility of insertion or deletion. अगर करते हैं तो definitely it will result into changing the entire database. So in order to overcome these limitations, we are going for the concept of dynamic multi-level indexing. गोल हियर इज कि जब हम इंसर्शन डिलीशन जैसे ऑपरेशंस परफॉर्म करते हैं, इट शुडंट रिजल्ट इनटू चेंजिंग द इंडेक्स फाइल, बिकॉज अगर पूरी इंडेक्स फाइल चेंज हो रही है, दैट इज एक्चुअली द ओवरहेड. So goals for going for the concept of dynamic multi-level indexing is insertion or deletion should not result into changing the entire index. नो ओवरफ्लो पेजेस. इंसर्शन के केस में हमने बोला था कि ओवरफ्लो पेजेस हो सकते हैं. देयर आर नो ओवरफ्लो पेजेस. एवरी इंडेक्स ब्लॉक except the root should be at least 50% occupied. This is the solution for the leave hole. जब आप entries delete करवाते जाते हो, if I don't want to shuffle, I want to delete all these entries, so it will result into the empty block, that is there is a hole, right? So in order to ensure that there is, it's not leaving the hole in the database file, so at least 50% occupancy is should be occupied. So in order to achieve these goals, we use the concept of B tree and B plus tree. Although B tree is a data structure which is also known as multi-way search tree, but I'm covering this concept of B tree and B plus tree under DBMS because it makes more sense here, because its application is for the indexing. Okay. Searching कैसे होती है, we'll also talk about that. We know that what is binary search. Binary search में a node is having just two block pointers or two children, but in multi-way search there will be multiple block pointers or multiple children for one node, and it depends on the order of a tree. Okay. Anyone having any doubt why we are going for the concept of dynamic multi-level indexing? So first of all, let's understand the difference between the B tree and the B plus tree. Okay, difference between B tree and B plus tree. So first of all, if we talk about B tree and B plus tree, here, obviously, both are the multi-way search trees, and all the leaf levels will be at the same level, because जब भी हम node में elements insert करवाते हैं, it always starts from the root node. But if there is a case of overflow, it will go for node splitting. So all the leaf nodes will be at the same level. That is the common point between B tree and the B plus tree. Difference is B tree does not support sequential access. It only supports random access. Whereas in case of B plus tree, we do have the concept of the sequential access. Sequential access is also possible. Okay, that is the major difference. ये difference कहाँ से आया? It's coming on the basis of the structure of a node. When we are talking about a node, node can be the leaf node or the internal node. यही होते हैं. Node can be the internal node. It's very important, because if you have understood these differences, then easily you will be able to uh, cover, or you will be able to understand the concept of B tree and the B plus tree. So internal node and the leaf node. So first of all, let's talk about the structure of the internal node. In case of B plus tree, all the nodes pointers will be maintained at the leaf level. Okay, so there is no requirement of the record pointer at the internal level. So if there is some entry, this is some key. So here we will be just having the keys, key 1 and key 2, and to the left there will be one block. Okay, here there will be few keys. There will be another block. यहाँ पे भी आपके पास कुछ keys आएंगी, and there is another block. Let us assume that here the order of a tree Order of a tree is 3. Order of a tree is 3 means the number of block pointers it can have. Now in the B tree, here we always maintain the copy of the internal record, और जो internal node पे आपके पास keys आएंगे, in their copy is always maintained at the leaf level, whereas the copy is not maintained at the leaf level in B tree. I'm going to consider the same tree here. I'll show you the difference. So 3 keys we are storing here, 3 keys. This is the internal node and this is the leaf level. Now here key is there, key 2 is there, and let's consider the database file as well. This is the database file where all the records are available. This is the database file. So first of all, let's talk about the B tree concept. So हर key के corresponding there will be a record pointer. It is pointing where this record is available in the database file. It is pointing where this record is available in the database file. यहाँ पे जो भी keys आएंगी, everywhere we will be having the key pointer and the record pointer. Key and the record, key and the record. So it is pointing here. Okay. So key and record, हर key के corresponding आपके पास record pointer होगा and it is pointing to where the record is available in the database file. So this indicates that here if I want to access K1 R1, so it's not in the sequential order, but definitely the elements within the key, वो चाहे B tree है या B plus tree है, elements within the key should always be in the ascending order. Whereas in case of B plus tree, here the copy of the key will always be maintained at the leaf level because it has to support the sequential access. For example, key k and record pointer, kx, ky and record pointer, and k1, its copy is maintained at the leaf level. That means internal level पे आपको record pointer देने की जरूरत नहीं है because it is pointed here. So all the keys are maintained at the leaf level, whereas it is not maintained in the B plus tree. So that's the first difference. K2. If you are maintaining the copy on the left hand side, then always maintain the copy on the left hand side. If you are maintaining the copy on the right hand side, then it's always maintained on the right hand side. Okay, ऐसा नहीं है किसी की copy left side पे maintain कर दी, किसी की copy right hand side पे maintain कर दी. That is not allowed. Why is it supporting the sequential access? Another difference is in case of B plus tree, at the leaf level, there is one block pointer that is pointing to the next node. There is one block pointer that is pointing to the next node. Now we have said that all the keys are available at the record level and one block is pointing to the next block, next block. So this way, sequential access is possible in case of B tree. Have you observed one thing that here we just have the block pointer. This is the block pointer. Block pointer means pointing to the next block. Record pointer means it is containing the address where that particular key is available in the database file. So we have block pointers available. We have only the keys available at the internal level. Whereas in case of B tree, block pointers be available here. Block pointer. Along with that, we are storing the keys as well as record pointers are also there. So this is the structure of the internal node and this is representing one block. इसके basis पे numericals आ सकते हैं. You need not to cramp the formulas. So here is the pointers. So if we talk about the structure of the internal node for the B tree, internal node, in the internal node, we are storing, if let us assume that order of a tree is P. That means the number of children or number of block pointers. Order or degree represents the number of children or the number of block pointers in the tree. Okay, but if the definition of order or degree is not same given in the question, so whatever definition is given in the question, you have to follow that. If nothing is given, then by default order or degree represents the number of block pointers or number of children for that node. So here I'm assuming that the order of the tree is b for both b tree and the b plus tree. So can somebody tell me that what should be the formula for the internal node? Formula kahin se nahi aaya. If you are comfortable with the structure, then easily you can write the formula in the internal node. If P order is there, that means block pointers kitne honge? P block pointers will be there. There will be P block pointers. Let us assume that if the order was 3, तो 3 block pointers आए तो keys कितनी आएंगी? 2. If the order is given as 4, that means 4 block pointers are there. 1, 2, 3, and 4. So what will be the number of keys? 1, 2, and 3. That means if the order of a tree is P, then we can store maximum P minus 1 keys. तो P minus 1 keys आएंगे और हर की के साथ हम record pointer भी store करवा रहे हैं. So there will be P minus 1 keys and the record pointer. You can write this separately. P minus 1 keys plus P minus 1 record pointers, that's one and the same thing. So this whole information should be stored in one block. This size should be less than equal to block size. इसके basis पे questions कैसे आते हैं? They generally ask that what will be the order of the tree if the block pointer is some size of block pointer will be given to you, the size of key and the record pointer will be given to you, and the block size will also be given to you. तो सिर्फ आपको ये p की value calculate करनी होती है. Okay, so get comfortable with these formulas. We'll be coming up with 4 formulas: internal node formula for b tree and b plus tree, लीफ नोड फॉर्मूला फॉर बी ट्री एंड बी प्लस ट्री. तो फॉर्मूलाज में कंफ्यूज ना हो, इसलिए बेटर है कि स्ट्रक्चर को अंडरस्टैंड कर लो. ओके, नेक्स्ट वन इज द इंटरनल नोड ऑफ बी प्लस ट्री. In the internal node of b plus tree, we just have the keys. Keys kitni आएंगी? P minus 1. So here we will be getting P block pointers and P minus 1 keys. That's it. And it should be stored, it should be less than equal to the block size. This is for the internal node for B tree and B plus tree. Next one is for the leaf node. In the leaf node, we just have the keys and the record pointers. There is no block pointer because leaf node means no children is there. ना तो कोई children है और ना ही ये next block को point कर रहे. So in this case, there is no block pointer. We just have P minus 1 keys and P minus 1. यहाँ पे मैंने अलग करके लिखा है ताकि आपको दोनों तरीके समझ में आ जाए. P minus 1 record pointers, and this should be less than equal to the block size. Now let's go for the leaf node structure of the B plus tree. So here also we have P minus 1 keys. Is it going behind my image? Yes. So for 2 seconds, let's switch off the camera. Okay, P minus 1 keys are there. Her key के corresponding record pointer is there. P minus 1 record pointers are there. After this, I'll be writing record pointers as RP and block pointer as BP. And along with this, since it is pointing to the next block, that means one block pointer is there. So one block pointer is also present at the leaf level. And this should be less than equal to block size. Makes sense? So this is the formula for the internal node of a B tree. इसके basis पे numericals आते हैं and we will discuss the numericals in the master class. Okay, I'll be just taking the numericals which were asked in the GATE exam. So this is the formula for the leaf node of B plus tree. Anyone having any doubt till this point? We have not started with the construction. We have just gone through the overview of B tree and B plus tree. These are the formulas for the leaf nodes. Okay. So what points we have discussed in B tree and B plus tree? We have said that in B plus tree, every key is available at every key is available at the leaf level, and each block of the leaf level, each block at leaf level points to the next block. That is, one block pointer is used. One block pointer is there at the leaf level. And because of this, it results into the sequential access. Since we are saying that every key is available at the leaf level, this means that when we are going for node splitting, during node splitting, maintain a copy of the key at the maintain a copy of the key at the leaf level. Splitting का मतलब ये जो भी node split होके internal level पे जा रही है, its copy has to be maintained at the leaf level. For example, I want to insert the elements like 1, 3, 5, 2, 4, something like this. So first of all, within a node, all the keys will be in the ascending order. Another important point to note here is in a block, keys should be in the ascending order. Keys should be in the ascending order. So if I want to construct this, I want to construct a B tree or B plus tree from these nodes. So let us assume that here the block or the order of a tree is 4. That means maximum number of keys. अगर order 4 है, block pointers 4 है, तो maximum keys एक node में कितनी हो सकती हैं? That is 3. I want to construct it using the B tree and B plus tree. Now here, first of all, we'll take a node. जब भी elements insert होंगे, it will always be in the ascending order. 1 is inserted, that's fine. Maximum keys 3 आ सकती है, कोई issue नहीं है. Then next one is 3, that's also fine. Next one is 5, that's also fine. Now 2 wants to join here, but this is a case of overflow. If it's a case of overflow, then we'll go for the concept of node splitting. तो किसके बेसिस पे करेंगे? ऑब्वियसली नोड को स्प्लिट कर रहे हैं, सो विल बी डूइंग दिस ऑन द बेसिस ऑफ द मिडिल एलिमेंट. सो हियर जब आप सिक्वेंशियल ऑर्डर लोगे, दैट कम्स आउट टू बी 1 2 3 5. 4 elements are there, so you can split a node on the basis of 2 or on the basis of 3. Let us assume that we are doing this on the basis of 2. This is known as right biasing because more number of elements are present on the right side. So when the node splitting is taking place, here we'll get 2 is going to अभी तक ये एक ही node थी, so this is the leaf node only because it's not having any children. So when 2 is going to the internal node, at the internal level, its copy is not maintained at the leaf level. जो भी elements left side पे है, since this is a multi-way search tree, so smaller elements should be present on the left hand side and the greater elements should be present on the right hand side. So here we have 1, remaining slots are empty. On the right hand side, there will be 2 elements. Have you observed one point here that I'm not maintaining the copy of 2 at the leaf level. 2 is nowhere available at the leaf level. This is how the node is splitted in the B tree. But if we talk about B plus tree, let's consider the same concept. Okay, let's finish this. So this is inserted. Next one is 4. We'll do the comparison here. 4 is greater than 2, so it should be present on the right hand side of 2. 4 should come here. One empty slot is there, but here we have 3 and 5. These elements should be in the ascending order. 4 को आप यहाँ पे add नहीं कर सकते. So what we need to do is 4 should come here and here will be having 5. This is uh, how we insert the elements in the B tree. Anyhow, we'll be talking about these in detail in tomorrow's session. Okay, I'm just giving you the overview so that you get comfortable, so that कल आपको कोई problem नहीं आए. Next one is B plus tree. In B plus tree, everything will be same जब तक node split नहीं होती है. So first of all, we are getting. Oh, I'm so sorry. I guess everything went behind the ticker. Let me repeat this. I didn't notice actually. Okay, so यहाँ पे बेटा मैंने क्या बताया था कि नोड एलिमेंट 2 के बेसिस पे स्प्लिट हो रही है, तो 2 is available here, and since to the left of 2 we have 1, so we'll be storing 1 only, and to the right we have 3 and 5. Hope it's visible now. Okay, so we have 3 and 5. I want to insert the next element. एक node में आपके पास 3 keys आ सकती है. So 4 is greater than 2, so it is going to the right side. But 5 के बाद नहीं आ सकता because this should always be in the ascending order. So we'll get 3, 4, 5. This is how we insert the elements in the B tree. B plus tree में भी insertion ऐसी होती है. सिर्फ और सिर्फ difference कहाँ पे आएगा? When we are going to split the node. So here 1, 3, 5 आपने इंसर्ट किए, 1, 3, 5 आ गए यहाँ तक, कोई प्रॉब्लम नहीं है. Now we have to go for, we want to insert the element 2. So I need to split the node. जैसे ही node को split करेंगे, we have done the splitting here on the basis of 2, तो मैं यहाँ पे भी comparison purpose के लिए I'm splitting this on the basis of 2. On the basis of 2. 2 के left में we are having one element. This is how we did the splitting in B tree. So in one block there can be 3 keys. Okay, to the left of 2 we have 1. 1 is smaller than 2, so it should be a part of the left block, left child, and 3, 4, 3, 5 is greater, so it should be a part of the right block. Okay, now this is how it looks like in B tree, but in B plus tree we have to maintain a copy of the splitted key at the leaf level. तो आप किसी भी साइड पे मेंटेन कर सकते हो. आई एम मेंटेनिंग दिस कॉपी ऑन द right side because already we have used the concept of the right biasing. That means जब हम split कर रहे हैं, more number of elements are on the right side. अगर copy भी right side पे maintain करेंगे, so right side जल्दी fill हो जाएगी and we may have to go for more number of node splitting. So that's why I'm maintaining the copy on the left side, but it's completely your choice. Moreover, it will depend on the scenario which will be given in the question. So here the copy is maintained at the leaf level, whereas it is not maintained at the leaf level in B tree. This is the difference between B tree and B plus tree. I want to insert the next element, that is 4. 4 कहाँ पे जाएगा? 4 is greater than 2, so it will be going to the right side. जैसे हमने B tree में किया right side. Right side में we have the keys 3 and 5, but it should always be in the ascending order. So here we'll be getting 4 and 5. So this is the resultant B plus tree which we have obtained after inserting 5 elements 1, 3, 5 to 4 with the order of the tree as 4. And here there will be a block pointer, it is pointing here. So you can see here it is providing the sequential access. 1, 2 access hoga first block se, then 3, 4, 5. So sequential access is possible, whereas in this case it's not possible. Common point is all the leaf nodes are at the same level. So this is about the major differences between the B tree and the B plus tree. Let's quickly go through the differences, and after that we'll end our discussion. In the next session, that will be tomorrow, we will learn more concepts about the insertion of the elements in the B tree and B plus tree, and also we'll talk about the different types of questions. Okay. So first of all, pointers, a basic basis of comparison, B tree and B plus tree दोनों का comparison कर रहे हैं. So if we talk about the pointers, जितनी भी, I'm basically talking about the record pointers, or you can also call this as the data pointers, or this is also known as the data pointers. So record pointers or data pointers are available at both the internal level and at the leaf level in B tree. But in B plus tree, it's only maintained at the leaf level because each and every key is available at the leaf level. तो हमें internal node पे pointer लेने की ज़रूरत ही नहीं. Okay. So here comes the first point. All the internal and the leaf nodes, sorry, internal or leaf nodes में data pointer होगा, whereas in case of B plus tree, only the leaf nodes will be having the data pointers. First and the major difference. Second one is when we have to search for the key, all the keys are not available at the leaf level. Though search often takes more time as compared to B plus tree, whereas since in B plus tree all the keys are available at the leaf level, so the search is faster as well as it is more accurate and reliable. Third difference, on the basis of the redundant keys, B tree में we are not maintaining the copy of the key. जब भी node split हो रही है तो हम leaf level पे copy maintain नहीं कर रहे हैं. So this indicates that there are no duplicates of keys maintained in the tree. Whereas in case of B plus tree, duplicate keys are maintained and all the nodes should be present at the leaf level. Insertion. Insertion in B tree will take more time as sometimes it's not predictable, whereas insertion in B plus tree is easier and it always and the results are always the same. Next difference, deletion. Deletion of the internal node is very complex and the tree has to undergo through a lot of transformations. क्योंकि जब हम किसी भी key को insert करते हैं तो we look for the case of overflow. अगर overflow हो रहा है then we go for the node splitting, and if it's a case of underflow means अगर minimum number of keys से नीचे keys आती है then we call that case as the underflow, as we have already defined that in the multi-level, in the dynamic multi-level indexing in B tree and B plus tree, at least 50% occupancy should be there. Okay, so it has to go through a lot of transformations if it's a case of underflow, whereas deletion is easy in case of B plus tree because all the nodes are available at the leaf level. तो आपको search करने की ज़्यादा ज़रूरत नहीं. Next one is leaf nodes. Leaf nodes are not stored as the structural linked list. Linked list nahi hai because one block is not pointing to the next block. Whereas in B plus tree, since the block pointer is available which is pointing to the next node, so it's forming a linked list. So leaf nodes are stored as structural linked list. Next one is access. So sequential access to nodes is not possible because कोई node आपके पास internal level पे है, कोई key आपके पास leaf level पे. So sequential access is not possible in case of B tree, whereas sequential access is very much possible in case of B plus tree. If we talk about the applications, B tree is basically used. So basically जो हम B tree use करें, that is for the searching purpose only. And so it is used in the search engines or in the databases, whereas B plus tree is used in multi-level indexing, dynamic multi-level indexing, or database indexing. So that's why since the application for B tree and the B plus tree is in the indexing, so that's why we are covering this concept under indexing. Otherwise, you can also treat this like B tree is nothing but this is a multi-way. You can also call this as a multi-way search tree. Just the way we were having the binary search tree. Binary means two children are there. Yahan pe multiple children are there, but smaller elements are on the left hand side, greater elements are on the right hand side. Condition is same as that of the binary search tree. So that's why this is also known as multi-way search tree or M-way search tree or M-way search tree. So this is all about this session. Tomorrow what we'll be doing is we'll talk into more details of the B tree and the B plus tree. Okay, and also we'll talk about the different cases when we are inserting a node. तो जैसे अभी हमने left right biasing की बात की, so we do have a concept of left biasing and right biasing, and sometimes they may ask in the exam that if you have to insert the given keys in the B tree, then what will be the minimum number of node splittings? अगर minimum number of node splittings की बात करें, then in that case we have to consider the concept of key redistribution. Okay, so if there is any possibility that sibling can help, then will not go for the node splitting, क्योंकि जब number of node splittings बढ़ती हैं तो number of levels in a tree is going to increase, and we know that the IO cost is depending on the number of index levels. Basically here each level of a tree is representing the index level. What I'm saying is, if this is the case, this is the second level. Let me call this as block 1. This is how we can see this. Okay, इसके आगे भी हो सकते हैं. So अगर मैं इसको rotate कर दूं, then this will look like this is your index file. Here we have one block, here we have another block. This is how we had seen the index file. और यहाँ पे आपके पास, here you have the database file. This is your database file where actually the records are present. So here also we had the database file which was divided into the blocks. Database file. So this is your first level index, second level index, right? This is first level index and second level index. So basically we know that this is multi-level indexing, and in the multi-level indexing IO cost is number of index levels plus 1. So if here the number of levels in a tree will increase, that means simply the number of index levels are increasing, so it will increase the IO cost of accessing the data. IO cost को ही तो reduce करना है. So that's why we'll consider the concept of key redistribution. अगर key को हम redistribute करके height increase होने से बचती है, so we will go for that. So the main agenda is to keep the height of a B tree as minimum as possible, because it is directly impacting the IO cost of accessing the data. Okay, so all the leaf nodes of the B tree or the B plus tree must be at the same level. B tree hai ya B plus tree hai, it should be at the same level. Here is the definition for the order. Order is nothing but that is the maximum number of block pointers in the B tree node. And all the leaf nodes in the B tree, there should not be any empty subtree. That means at least 50% occupancy should be there. 50% occupancy. Correct? Anyone having any doubt on this point? So we'll end our discussion here. Tomorrow we'll learn that how to insert the elements in the B tree and how to delete the elements. So that will be covering tomorrow. So those who are new on this channel, guys, we have our Telegram group in which you can get the PDF of all the YouTube sessions. इस session की PDF में आपको next 10 minutes में आपको मिल जाएगी in this Telegram group. So you can search for Shefali ma'am Testbook. I'm going to share my screen. You can see where the link is available. Also, अगर if there is any doubt in the concept that we have covered today or in the previous sessions, you can post your doubts or problems in the group. If you want to directly interact with me, you can also do that, and you can post. You can also participate in the quiz and the poll. Let me show you my screen. Okay. So I hope it's visible to everyone. So when you go to the description of this video, first link is for the master class. Okay. So in the master class, we are covering the previous year questions of the concepts which we have covered in YouTube session. तो जो आज और कल मल्टी लेवल इंडेक्सिंग B3 का कॉन्सेप्ट हम लोग कवर कर रहे हैं, I'll be taking its previous year questions on Wednesday or Thursday, so that Monday or Tuesday में you get comfortable, क्योंकि कल actually properly concept होगा, because lot many questions have been asked on the basis of this concept. So we'll be covering these questions on Wednesday or Thursday. And apart from that, you can, if you are preparing for the NIC, you can join this NIC batch. And yeah, here, this is the third link, join Gate Super Coaching Telegram. So this is the link for the Telegram group. So you can follow this link in order to join the Telegram group. And if you are interested in joining the Super Coaching Gate batch, Super Coaching means in the Super Coaching batch, you will get the detailed recorded sessions of all the subjects, multiple sessions को आप access कर सकते हो, कोई limit नहीं है number of accesses पे. That is the benefit, and lot many courses are available. If you want more and more number of examples, you can follow multiple educators for the same topic or for the same subjects. So I'm going to the full course. So here you can see that full course is provided by the Gate Forum, by Digimento, by Nimbus Learning, and by me and my team. You can also see the rating. किसी भी course की rating 4.8 से कम नहीं है. That means quality of the content is there. So you can take the benefit of this. If you have the super coaching, you can go through the profile of the super teachers, demo classes you can take, so that you get confident. आपको एक idea कि whether you are interested in joining this batch or not. But if you are interested, so currently Maha Budget sale is going on. You will get the maximum benefit, and you will get these courses at the minimum prices. I'll show you that what is that. So live series is going on. Mock test आप access कर सकते हो. Study notes. Study notes will be available in the PDF format for all the subjects that's available. For engineering mathematics, you can see here 7 plus PDF notes are there. For general aptitude, 4 plus PDF notes are there. For formula notes, 9 plus PDF are available. Formula notes are basically the short notes जो आपको एग्जाम से पहले क्विक रिवीजन में हेल्प करते हैं. ओके, क्योंकि उस टाइम पे हम डिटेल नोट्स को नहीं पढ़ते. वी डोंट प्रेफर गोइंग थ्रू द डिटेल नोट्स, एंड हियर इज a folder for the detailed notes. So you can see here for programming and data structure, basically we have 5 units. So from each unit we have one PDF. The operating system also we have approximately 5 units. So 5 PDFs are there. So it depends on the topics. Accordingly, the PDFs are available. Without subscription, you won't be able to access it. आपको यहाँ पे छोटा सा lock दिख रहा होगा. That means in order to unlock that, you need the subscription. Okay, so as soon as you click on the buy now, it will take you to the pricing page. So pricing may it will show you that we have three plans: 1 year plan, 2 year plan, and 3 year plan. 1 year plan is basically for the students, those who are in the final year or those who are pass outs. 2 year plan is beneficial for the students जो second year, third year में. इस टाइम पे मैं ये recommend करूंगी go for this 3 year plan. Basically this is 2 year plan, but in this महा बचत सेल आपको 2+1 मिल रहा है. जो भी आप प्लान ले रहे हो उसके साथ आपको 50% एक्स्ट्रा वैलिडिटी मिल रही है. दैट मीन्स इफ यू आर गोइंग टू परचेज कोर्स फॉर 1 year, दैट मीन्स 12 months, तो आपकी सब्सक्रिप्शन वैलिड होगी फॉर 18 months. Similarly, 2 year plan है. 2 year means 50% is 1 year. So 3 year का प्लान आपको 14,790 14,774 में मिल रहा है। तो अगर आप इसकी एवरेज निकालते हो, सो पर ईयर इट इज नॉट इवन कॉस्टिंग 5,000 रुपीज, राइट? पर ईयर एक साल की फीस 5,000 भी नहीं है। एंड दिस इज बेनिफिशियल फॉर द स्टूडेंट्स फॉर सेकेंड ईयर वालों को, फर्स्ट और सेकेंड ईयर को मैं स्पेशली रिकमेंड करूंगी इस बैच के लिए, बिकॉज बच्चे ये आपको आपके सेमेस्टर एग्जाम्स में भी हेल्प करेगा। सेकेंड ईयर और थर्ड ईयर में जो भी आप कोर टेक्निकल सब्जेक्ट्स पढ़ते हो, all those subjects are the part of the GATE syllabus. Moreover, अभी आपने देखा होगा ISRO notification is out, तो ISRO के कल हम लोगों ने previous year questions किए थे, right? तो जो भी questions है, या तो वो previous year GATE questions है, या फिर it is from the concepts of the GATE. तो अगर आपने गेट की प्रिपरेशन अच्छे से की है, तो आपको ये अलग से एग्जाम्स की प्रिपरेशन की जरूरत नहीं है। DRDO notification is out, that is also on the basis of the GATE. तो जितने भी ये PSUs आ रहे हैं, अगर they are conducting their own exams, so its syllabus will be very close to the GATE syllabus, and the types of questions will also be same as that of the GATE pattern. Okay, and the other thing is it will give you the benefit in your semester exams, plus it will give you the benefit in your placements. प्लेसमेंट ड्राइव में कैसे हेल्प करेगा? फर्स्ट राउंड इज यूजुअली द रिटन राउंड, तो उसमें 4-5 टेक्निकल सब्जेक्ट्स है, लाइक DBMS, ऑपरेटिंग सिस्टम्स, एल्गोरिथम्स, डेटा स्ट्रक्चर्स एंड प्रोग्रामिंग। तो इसके बेसिस पे MCQ क्वेश्चंस आते हैं। सो इफ यू हैव अंडरस्टूड ऑल द कॉन्सेप्ट्स इन डिटेल, तो आपको अलग से प्रिपरेशन करने की जरूरत ही नहीं है। गेट में आपने एप्टी भी प्रिपेयर कर लिया, आपने टेक्निकल भी प्रिपेयर कर लिया, तो उसके अलावा कुछ बचता ही नहीं है। सो एक बार तो आपको प्रिपेयर करना ही चाहिए। सो it's up to you which one course you want to take. So I guess 2 year will be beneficial for 1 year student, first year student, second year and third year student. This is for 4 years. तो ये तो सिर्फ और सिर्फ फर्स्ट ईयर के स्टूडेंट्स ही ले सकते हैं, उन्हीं को बेनिफिट है। सेकंड थर्ड ईयर को कोई बेनिफिट नहीं है 3 ईयर प्लान का। ओके, सो इफ यू वांट टू टेक द मैक्सिमम बेनिफिट of the discount and the other benefits, then don't forget to use the code that is Shefali S. Okay, this is my first name SHEFALI and S. This coupon code is also available in the description box. जैसे यहाँ पे आपके पास link है, join super coaching gate. Immediately after that, coupon code is available. You can use this coupon code in order to get the subscription. Okay, so this is all from my side. If you guys have any doubt or any query, please let me know. आई होप आपको समझ में आ गया कल हम लोग क्या करने वाले हैं। फॉर दैट इट्स वेरी वेरी इंपॉर्टेंट कि आप आज वाला सेशन रिवाइज करो। एंड लेट मी टेल यू दैट व्हाट is our schedule. Monday to Friday we are having the sessions. Monday to Friday we are daily having 2 sessions, one at 4 p.m. Duration of this session is 1 hour. बट कल वाला सेशन थोड़ा सा लेंथी जाएगा बिकॉज we have to cover both the concepts B3 and the B plus 3. So we'll be deriving few more formulas in this YouTube session. And the second one is for a masterclass that is at 8 p.m. 8 to 8:30 p.m. This is a masterclass. Apart from this, Saturday and Sunday will be having the marathons. अभी हम थोड़ा सा slow चल रहे हैं because we have a lot of time, but most probably from this week I'll be taking the marathon sessions as well. Time will be updated in the Telegram group, so for that you have to join the Telegram group. And Saturday and Sunday I have started with one more series that is for ISRO. Goal is ISRO 2023. Notification is out. Applications आप लोग fill कर सकते हो। ISRO की applications fill करने के लिए window है। It has started from 25th of May and it will go till 14th of June. To 14th of June. Total CS में 47 vacancies are there. So if you want to join ISRO, you are a final year student or pass out, so you can still fill the form. You have approximately 15 to 17 days to fill out this form. So this is all from my side. Anyone having any doubt or query? And definitely if you want to get the test book pass, टेक्स्ट बुक पास में सिर्फ और सिर्फ आपको टेस्ट सीरीज मिलेगी. So for that also, you are getting a lot of benefit. You are going to get this for 250 rupees only. So you can take the advantage. Any queries? All right, I guess there is no query. So today we'll be having the master class as well. That is at 8 p.m. And in that we will be discussing the questions on the basis of serializability. Friday हमने serializability के questions किए थे. कुछ questions रह गए थे because lot many questions were asked and in 30 minutes it wasn't feasible for me to cover all the questions. So we'll be having one more session today on the PYQs of serializability. So do join that session and please try to revise the concept. अगर concept clear है तो आपको questions करने में मजा आएगा. Okay. All right, guys. Thank you. I'll see you at 8 p.m. Bye bye.